We all grew up memorizing that there are 9 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Then all of a sudden, we were told that Pluto is not a planet. Most of us accepted this. Some of us still claim that Pluto was treated unfairly. So, do you know exactly what happened at that time that Pluto was kicked out of being a planet? For example, why is Mercury a planet and not Pluto? What determines what is and what is not a planet? And do you think there are 9 other planets beyond Neptune? Let's take a look. When we say solar system, we usually think of a structure with the sun at the center and planets revolving around it. But in fact, our system does not only consist of our star and planets. For example, there is a place between Mars and Jupiter called the asteroid belt. This belt is approximately 3.54 astronomical units away from the Earth. In other words, they are 3.5 to 4 times the distance between the Sun and the Earth. The meteorites in this belt that revolve around the Sun could not have become planets in time. They consist of pieces of rock, but among them there are also giant objects like Ceres, which is 14 times smaller in mass than Pluto, but has managed to collect 25% of the entire mass in the asteroid belt. Or there is another asteroid belt beyond Neptune, which we call the Kuiper or Kuiper belt, but this belt has a difference from the one between Mars and Jupiter. Most of the objects here contain frozen water or ice. Therefore, when one of them collides with objects in its vicinity, or is affected by the gravitational pull of the planets, and deviates from its path and turns towards the sun, that ice begins to melt, and a tail consisting of dust and water, which we call a comet, is formed. Beyond the Kuiper belt, there is a much larger and much more mysterious region called the Oort cloud, which contains countless large and small celestial bodies. But that is the subject of another video. Now, the most interesting object in this Kuiper belt is undoubtedly Pluto. We have already seen the breathtaking discovery story of Pluto in the Story of the Three Planets video. So I will not go into it again here, but everyone who wants to understand how modern science works much better should definitely watch that video. I recommend watching it. So what does Pluto have or what doesn't, that it had to be removed from being a planet? Such an extreme thing had to be done. Now let's try to determine it. When we look at Pluto, there is a strangeness that is noticeable at first. In fact, there is no serious strangeness in its surface and structure like the other planets. It has a spherical geometry. Like the other planets, it revolves around the sun. In other words, the other planets revolve in elliptical orbits, while Pluto, I don't know, revolves by drawing triangles. But if you want to understand the strangeness of Pluto, you need to look at its qualities in a little more detail. For example, I said orbit. While all the planets revolve in elliptical orbits, which are almost circles, Pluto's orbital deficiency, that is the eccentricity of its orbit, is around 0.25. That is, it is very elliptical. If this number is 0, it means that it has a perfect circular orbit. The closer it is to 1, the more circular the orbit is, the more oval its eccentricity is only around 0.02. In other words, it is very close to a circle. Venus's K is 0.07. That is, it is almost a perfect circle. And this eccentricity is like this. You can think of it as the difference between the closest and farthest distances of the Earth to the Sun being 5 million kilometers, while for Pluto this difference is almost 3 billion kilometers. Because of this absurd difference, The temperature and the amount of light on Pluto's surface change in absurd amounts, but this is not enough to exclude a planet. Because, for example, Mercury's orbital eccentricity is also very close to Pluto's and is around zero point 0.2. Another oddity of Pluto is that while all the planets rotate around the Sun in roughly the same plane, Pluto's orbital inclination is around 17.2 degrees. Therefore, it cuts the plane in which the other planets rotate quite sharply, but there are anomalies in other planets that Pluto does not have. For example, Venus rotates in a 180-degree change of direction, meaning that all the planets rotate counterclockwise when viewed from above the North Pole, while Venus rotates clockwise. Therefore, Venus rises in the west and sets in the east, and Uranus is tilted 98 degrees, for example. Therefore, the orbital inclination is not enough to exclude Pluto. The anomaly is its distance from the Sun. Pluto orbits so far from the Sun that its year is equal to 248 Earth years, that is, since it was discovered in 1930. It has not completed a full orbit around the Sun. When it reaches the point where it was discovered again, it will be 2,178 on Earth. But a planet cannot be dismissed from being a planet just because of this. Isn't that right? Or think about its size. As we talked about in the story of the three planets, when Pluto was first discovered in 1930, it was thought to be a planet the size of Earth. But subsequent observations gradually began to reduce its size. First, in 1948, Gerard Kuiper said, yes, that Kuiper showed that Pluto could be at most the size of Mars. Then, in 1976, Dale K.C.K. Shank and two colleagues said that Pluto should not be thought to be large because it has an extremely reflective surface. Therefore, it looks much larger than it actually is, and when this is taken into account, its mass could be as much as 1% of Earth's. Finally, as a result of our more careful observations of Pluto, we found that Pluto is not alone. It has a moon half its size. So Charon was discovered, and thanks to Charon's discovery, the size of Pluto could be calculated much more accurately. Instead of being as big as the Earth, Pluto is even smaller than the Moon. Even think about it this way. Pluto's surface area is smaller than Russia's surface area, but being small alone cannot be a problem. After all, Mercury is also a very small planet, but it is still a planet. In fact, Pluto's most important anomaly is its location in the solar system. While all the other planets are between the Sun and the Kuiper belt that I just mentioned, Pluto is directly inside the Kuiper belt. In fact, it is even more accurate to say that Pluto is not only located in the Kuiper belt, Pluto is also the first Kuiper belt object we have discovered, because until Pluto, we were completely unaware of the existence of such a belt. This is a very strange situation. In fact, the first Kuiper belt object other than Pluto was discovered by David Jeet and Jane Liu on August 30th, 1992, 62 years after the discovery of Pluto, but they were the first to predict the existence of such a belt. In 1951, this was the Dutch astronomer Gerard Kuiper, whose name I just mentioned, so this place was named after him. Since 1992, we have discovered more than 2,000 objects in the Kuiper belt. What really digs into Pluto's well is that some of these objects we discovered in the Kuiper belt were very close in size to Pluto. With each new discovery we made, Pluto began to threaten us a little more than planethood. The discovery that would put the final nail in Pluto's coffin came in 2005 from an American astronomer named Michael Brown and his colleagues. In 2003, this team, who processed the data collected from the Palomar Observatory, discovered an object that they initially named 2003 UB313, later to be called Eris for short. This object was initially thought to be even larger than Pluto, but it was later understood that it was slightly smaller than Pluto's 2,377 click diameter, with a diameter of 2,326 click. But it doesn't matter, it is as big as Pluto in the Kuiper belt, and it has the potential to be even larger. It is now certain that there may be other objects larger than it. In the same year, a team led by José Luis Orti Moreno from the Sierra Nevada Observatory discovered Haumea 2, also in the Kuiper belt, with a diameter of 2,322 kilometers. Michael Brown had also independently discovered this object. In the same year, the same Michael Brown discovered another object called Makemake, measuring 1,434 kilometers. This astronomical hat trick by Michael Brown and his colleagues created tension in the astronomy community. Are we going to call all of these planets? If so, how many planets will there be in the solar system? 25, 40, or 50? And at that very point, the International Astronomical Union came to a strange realization. Until that day, no one had officially defined what was called a planet. The history of the word was so old that the word planet, meaning planet, came from the Greek word planet, meaning wanderer, and since ancient Greece, it has been used to describe celestial bodies that move much faster than the other stars we see at regular intervals in the sky, that is, that wander in the sky. The world we are standing on is clearly a planet. The definition of a planet has been used over the centuries by giants such as Pythagoras, Plato, Aristotle, Ptolemy, Copernicus. Finally, it was established as Astor's planet, or wandering stars. Therefore, when the Union was founded in 1919, it did not even feel the need to define such an obvious thing. But apparently the cards were being redistributed in the solar system. It was necessary to make an official planet definition. Thus, the Union members who gathered in Prague in August 2006 decided to make an official planet definition. Thus, the planet definition we use today officially emerged. According to this definition, a celestial body must revolve around a sun in order to be a planet. In this case, let me ask you this. How many planets do you think there are in the entire universe? 8. Yes, 8. And this number will probably never change, because we will never discover another planet orbiting the sun. Of course, this does not mean that there are no round root bodies like ours around other stars. Of course there are, but we officially call them exoplanets, not planets. By the way, Pluto meets this criterion because it revolves around the sun. In order for two bodies to be planets, they must have enough gravity to overcome the forces specific to solid bodies and reach the hydrostatic state. This is a more technical criterion, as you can see, but it actually says something very simple for a celestial body to be a planet. It should not be crooked or flat and should be close to spherical. This criterion eliminates rock pieces that could not become a planet like asteroids, but still revolve around the sun. But it does not eliminate Pluto, because Pluto has a geometry very close to spherical in 3. In order for an object to become a planet, it must have cleared its orbit and surroundings of other celestial bodies. In other words, objects that still have plenty of asteroids in their orbit or are in a belt cannot be planets. This is the criterion that killed Pluto because Pluto is a Kuiper object. In other words, its orbit and surroundings have not been cleared. It is full of other objects in the Kuiper belt. Of course, this is not only valid for Pluto, but also for other objects in the Kuiper belt, such as Eris or Makemake. And this is exactly why we can no longer call Pluto a planet. So what should we say? The International Astronomical Union has developed a new definition on this subject. If an object meets the first and second items that we just mentioned, but does not meet the third item, then we are looking at a fourth item. The object is a satellite of a celestial body that is larger than itself. If the answer is yes, we officially call it a natural satellite. If it is not a satellite of another body, then we call it a dwarf planet. Pluto is categorized as a dwarf planet because it meets these criteria. It has not been discovered, and the other large bodies that I mentioned that dethroned Pluto are all dwarf planets. This category change is mocked in popular culture in a half-joking way. For example, think of Cem Yılmaz's jokes about Pluto, or the countless mug and t-shirt designs that say that Pluto continues to be a planet in our hearts. It is even possible to see news that Pluto is a planet again from time to time. These are mostly mistakes that arise from taking seriously the posts made as April Fool's jokes, or from the headlines exaggerating the jokes of an important person, like the former head of NASA. These are, of course, nice things that increase interest in science, but no, Pluto is not a planet and will never regain its planet status, because Neptune's huge gravity causes a situation on Pluto called orbital resonance. It creates a lock. This lock fixes the rotation times of Neptune and Pluto around the Sun. For every 3 revolutions of Neptune around the Sun, Pluto can always complete 2 revolutions. This fixed speed greatly reduces the possibility of Pluto being blown away by Neptune. This situation, combined with factors such as Pluto's extremely small mass and the fact that the Kuiper belt is full of objects that move very little, makes the probability of Pluto clearing its orbit practically zero, even after hundreds of millions of years. And this is a very good thing because although our hearts, which choose to be on the side of the oppressed, put Pluto in the category of the oppressed, the discovery of the Kuiper belt, which Pluto is also in, actually whispers very important secrets about ourselves to us. Ask yourself why there is such a thing as the Kuiper belt. Why couldn't a planet form there and collect all the Kuiper objects in its body? Because when the solar system was formed, the mass that formed the system was scattered around like a disk. In other words, the Kuiper belt is today. The interior of the solar system is the same, consisting of countless large and small dust and rock particles. Some of them started to cluster at certain points, and first formed the planetary building blocks that we call planetesimal. They attracted the surrounding matter and turned into protoplanets. Some of these protoplanets cleared everything along their orbits and turned into the planets we know today. However, sufficient clustering could not occur in orbits at a certain distance from the Sun. One of them is the Kuiper belt. The other is the huge mass of Jupiter, which is very close to the asteroid belt, did not allow enough clustering of matter there. What caused this in the Kuiper belt? As I mentioned before, the density of Neptune's huge mass was very low, that is, the mass was very sparsely distributed over a very large volume. Therefore, sufficiently large nuclei could not form. It did not allow the formation of the gene. And this is a great thing in terms of astronomy because The Aki asteroid belt between Mars and Jupiter is a region that has been greatly affected by the presence of the Sun and other planets in the vicinity. The rocks here are the scorching heat of the Sun. Therefore, they have undergone a lot of changes over billions of years. However, the Kuiper belt is so far from the Sun and other planets that whatever our solar system was 4.6 billion years ago is the Kuiper belt. It currently has almost the same features. Therefore, people can understand how being in a closer orbit to the Sun affects the planet's surfaces and depths by examining the asteroid belt and the Kuiper belt together and comparing them with each other. This is extremely valuable in terms of understanding the dynamics of star systems. In other words, the Kuiper belt offers us a laboratory opportunity of systemic size. However, it is very, very difficult to reach there with our current technology. So far, the only vehicle that has been able to send to the Kuiper belt was the New Horizons vehicle, which provided us with the clearest photos of Pluto taken to date. Voyager 1 and 2 actually passed through the Kuiper belt, but at that time this belt had not even been discovered yet. Therefore, it could not send us any meaningful data from there. By the way, even this simple fact tells us something very important. In the movies, spaceships passing through the asteroid belts try to escape from the meteors by making such extreme maneuvers. But this is a huge load of nonsense. The distance between two objects, you will randomly choose one after the other, in the asteroid belt is around 1 million kilometers. It is 1 million by 2030 meters. It is practically impossible for a spacecraft to see two asteroids at the same time, let alone have to maneuver to avoid them. Think about it that way. It is thought that this average distance in the Kuiper belt is not just 1 million, but millions of kilometers. Space is that huge. This is how you will understand why Pluto is not a planet, but why it cannot be a planet. It gives us very valuable information. We need to learn to accept it as it is, not as we want it to be, like all the other facts in the universe. When we do this, we can reach the real thing. Pluto is not a planet, and thankfully it is not. If you like this video, you should definitely watch this video about the multiverse. See you in the next video. Goodbye.